Okay, it is started. We have begun. Let's see, what are we doing here? This thing, no, we don't want to see that. We don't want to see that either. There it is. You probably don't want to see that either. What is that? I don't even know. Let's just go to the bottom. Okay, so I will put the rules down here. Give me a sec. So I'll give you this at the end, just so you know. Here, what I have here is test 3, easy, take-home version. That's literally what it says at the top of this. So let me explain the rules for you. Here's the rules. Whatever. Anything goes.
Oh.
Okay, that's number one. Number two. Okay. So, yeah, in other words, you use whatever resources you want. Don't feel like you have to sit down in a, like quiet environment. You can even ask your friend, I don't care. But you have to show your work and do your work. So, number two, it's optional. You might wonder, what is the benefit?
What does that say?
I know, it's because, I don't know if it's my nib, it may be my nib, or it might be my iPad, or it might be the Apple Pencil, that something's getting cheesy up here. Hopefully by the end of the semester, or maybe next year, I'll have new nibs or whatever I need. So, okay, so it's optional. That's what that's supposed to say. Option, wow, that looks terrible. Let's try again. So this easy test take-home version is optional. By the way, here, this, what I'll give you in just, well, at the end, this is the test I wish I had given you. After doing the what's it called, the key, and making up the key and then grading your test, I was like, why? I was doing my, oh, Gabriel, there you are. So I was face palming all weekend. So just so you know, I admit it was an ugly test. So this easy take-home version, that's the test I should have given you, but I didn't. What was I thinking? Anyway, so this is optional. However, here's the third thing. Is what?
Here it is. Here's like the little.
No. This is it's all carrots, no sticks.
All carrots, no sticks. Oh, surely there's no stick.
Yeah, anything goes. Optional.
Free lunch.
Free lunch. I'll put it on the list. Number four is, here's how I do this, is I will average I got to make sure that this is clear, so just a minute. Do only the problems you got wrong. Okay, so for example, if you don't mind me taking a look at this and violating purple for just a minute.
Yeah, go ahead.
So for example, Darren got, wow.
Okay.
So Darren got number 1A wrong, but he got number 1D right. So on the easy take-home version, Darren can do number 1A, but can skip number 1D because he already got that one right in the hard version.
Even
So,
if it's a different problem.
what do you mean?
So it's like 1D the same on that test as
They
it is
match.
on this.
Okay, they match in the sense that here's 1D on your test is second order differential equation with two initial conditions. On the easy version, it's a second order differential equation with two initial conditions, just a different second order one, and probably an easier one, just so you know. So like number 1B, popular one to get wrong. Number 1B is a linear differential equation on your exam, and on my exam, or the easy take-home version, it is also linear, but it's easier. I hope it's easier. I don't know. Maybe you'll find it's harder. I don't know. But anyway, so that's number 4. I don't know where this free lunch is coming from. No, let's make dinner. So that's going to be on Tuesday. next week.
What?
Yeah, so look for emails about the free dinner next Tuesday.
I'll be at your house.
No, it's not at my house. I think it's at the PSU. It's the math picnic. I think it's next week.
Oh, he's not even really.
I am not. Yeah, come on down. Come on down. All math majors, minors, or anyone even quasi-affiliated with math. You come on down. We'll have, I don't even know what we're having.
It's on tax day?
I think it's Tuesday.
It is on tax day.
It's on tax day?
Yeah.
Well, we need a free dinner that day.
Yeah.
Okay, so I'm pretty sure, check your emails just to be sure, because you know how Dr. Brad likes to send those emails? Does he send emails to you? I always wonder because he doesn't include me. So I hear about these emails and I'm
Get
like,
emails from him like daily.
every day?
Not really, but
Okay.
it feels like it.
Okay, well anyway, yeah, so free dinner Tuesday. Okay, but do only the problems you got wrong, and then number five, so don't burn this one yet. So hand in both copies on Monday, the 17th. This I'll show you, it's in the homework, so it's in the homework to remind you, but also hand in both copies. Here's what I'll do. Let's say if you do all of, let's take this fictitious person here. Just a minute. There. This fictitious person got a 50 on their exam. Let's say that they do every problem that they got wrong, but on the easy version. Then I'll change that to a 75. You understand how this is going to work? Oh, is this what you wanted me to do, or you were?
That's exactly what I wanted to see. Perfect.
Okay, so you're happy. I was worried that you were sad.
No,
Okay, yeah. So if you got a 80 on this exam, then I'll split the difference. If you do all of the ones, now if you don't do them all, then I'll have to prorate. I'll do my best to prorate it. Like if you only do half of them, you got an 80. You should have gotten 10 points. You'll get 5 points. Whatever. You'll get some points. It's a little bit, maybe a little bit difficult for someone who might get over 100 on the first exam. I guess I'd have to split the difference and pull them back down. But no, I don't know who would be in that situation. But yeah, you can choose. It's totally optional. Optional. You don't have to do this. So if you're in that situation, you don't have to do this. Okay, so hand in both copies on Monday. That's this another test question mark thing. Yes, another one, but it's mainly so that it gives you something to do while I'm gallivanting around the North Shore in Massachusetts. Okay, so there's that. Yeah? No? Yeah.
So
Yep.
this number at the top is not weighted, but there was hidden bonus questions.
Yeah, there's
Okay.
hidden bonus questions. Specifically, it was numbers, and you'll know because I'll put a +4 or whatever it was on your test. So it's like number 3 and number
I must have gotten
9.
it wrong.
Yeah, if you don't have a plus anywhere, it means you got the hidden bonus questions wrong. And this was after the fact hidden bonus questions.
Wait, so are you still trying to get those bonus questions, or are they not on the easy?
No, they're on the easy one, but I made them super easy, so they aren't bonus questions on here.
Gotcha.
Okay.
So how
Oh yeah, so why did I?
That's what I'm saying. So how
So
did
no
it
one should
affect-
do that.
Yeah, why would I even do that? That's a good question.
So can we still just do them? I mean, even the people that got the bonus questions could do those bonus questions. And get
This is gonna-
Sure, you can do them, and you get half the bonus points that I gave to the bonus.
Okay,
points.
cool.
How's that? Yeah, yeah.
That's- and
So it's
points-
numbers.
Points are points.
Numbers 9 and 3 are the two. So
Alright.
I'll make sure that you'll remind me to give you these before we leave. But we do have a couple other things to do. Derive those transforms, flight plans, and another test with the 2 exclamation marks. Okay, so first off, let's derive the transforms. So this is pretty straightforward, and then I'll give you your marching orders. Actually, yeah, let's just derive the transforms first. So we want to do the Laplace transform of something like this. T squared times sine of t. So this is what we're doing today. Let's see, let me make sure that I'm in the right section. Hold on a sec. 7 point, yeah, this is a quickie. We are, is this it? This is it. Yes, this is it, good. Really? Okay, so you have two options with this sort of a nightmare. So number one is you could do what you did on the test, or failed to do on the test, for problem number, where is it? Oh, number 4. So number 4 on the test, you could do that, or fail the one that you didn't. So here's option 1, which I would not suggest. T squared sine of t, sorry, e to the negative st. That's it. Now, let me just explain why I would not recommend this tech here. And the reason is that you've got like, it's bad enough when you have a single product, because when you have a product, you have to do integration by parts. So with this, I have 2 products. So essentially, I'm going to have to do integration by parts twice. That is no good. This is the sort of thing that you would expect on test 3. We are beyond test 3 now. So let's do it the easy way. The easier way is this, that when you approach a problem like this, let me just erase that horrendous, I don't want to do that. I don't want to be angry anymore. I want to be happy. So the right way to do this is to use a little formula. It's in your book. It's theorem 7.4.1. But here's the gist of this theorem, is that when you approach something like this, you're going to do -1 squared. I'll explain where everything comes from in just a minute, times the second derivative of the Laplace transform of sine. Wow, that was a bad example. Well, at least it saves us from some of the pain that we would have had to go through, because this is still going to be pretty ugly. Okay, so here's what we're going to do. Now, let me just, in general, we'll come back to this, but you want to know, what does the general thing look like? Well, here's the general thing. If we're doing the Laplace transform of t to the n times some function that we already know the Laplace transform for, what you're going to do is you're going to do -1 to the nth power times the nth derivative of the Laplace transform of f of t. So let's go ahead and do this for the problem that I have, and then we'll try a couple more, and then we'll call it a day. I'll give you your marching orders. Although there's the flight plans and then another. We'll get there. So it's not quite done when we get done with this little mini lesson. But anyway, so we've got this. Let's go ahead and do this. -1 squared. Hopefully we all remember, but if you don't, the table is on your test, Laplace transforms. It's also on, since basically I just took your test and rewrote it with easier problems, it's on this easy version of test 3, same formatting. The only thing that we lack is this is 2 separate pages, because I didn't have time to get it to the printer to get the tabloid size page. But anyway, getting back to this, hopefully you remember this, and if you don't, here it is, s squared plus 1. So notice what you're going to do. You're going to do the -1 squared, which in our case is just 1, and then you're going to do the second derivative of 1 over s squared plus 1. All right, well, let's go ahead and do the second derivative. I'll do it kind of in stages. The first derivative, you know what? I'd rather write it like this. And then I can do the first derivative. So this is the first derivative is going to be -1 times s squared plus 1 to the -2 times 2s. That wasn't too bad. But sadly, the next one is worse. So the second derivative will be, let's see, we're going to have to use the product rule, aren't we? So it's going to be 2 times s squared plus 1, 2s squared plus, minus actually, minus 1 times s squared plus 1 to the negative 2, sorry, this should be negative 3, times 2. Okay, just so that you know where everything came from, I feel like I'm teaching Calc 1 again, doing derivatives. No, nothing wrong with it. I'm not making fun of anyone. So here's this. The derivative of that is this times one of these. Oh, it's going to be hard for me to... And then this thing is right here. Yeah, this was a bad idea. Here, that one is right there, and one of those. Yeah.
That's fine.
It's okay?
Yeah.
It's the best I can do. Yeah, so the 2 came from the derivative. I had to use the chain rule. So, got another 2s. I should have written 2s instead of 2s squared. But anyway, there it is. And that would be the Laplace transform of t squared times sine of t. I could clean this up, and I will, just so you know. This thing is going to be, let's see, we have 4, I'm sorry, not 4. Give me a sec. 8s squared over s squared plus 1 to the third minus 2 over s squared plus 1 to the second. And I know what you want me to do now, and I'm going to do it. Combine these into a single fraction. So that's 8s squared over s squared plus 1 to the third minus 2 times s squared plus 1 over s squared plus 1 to the third, and then 8s squared minus 2s squared minus 2 over s squared plus 1 to the third. Sorry, it's such a mess. Let's clean it up. S squared minus 2 over s squared plus 1 to the third. So that's all just algebra. Oh, it's not just algebra. It is algebra. There's no just about it. It's hard. Anyway, that's it right there. So, there you go. The real power of this method is not so much in doing the Laplace transform of a product, although that is nice, but it's in the undoing of that, in the sense that if I had to do this inverse Laplace transform of this, it would be, I don't know, horrendous. You'd have to use, I would not want to do this. You'd have to use partial fractions with 3 denominators. I don't even want to think about it. So what you could do, though, is take that and realize that that is the derivative, second derivative, in fact, of this. And you might say, well, how would I know that? Well, try integrating it. So, which might be its own horrible thing, but it could be done. You could integrate this and see what happens. In fact, whenever you have the cube down here, that should be a hint that that's the second derivative of something, either sine or cosine. Okay, let's try another one of these just to see how this is going to shake out. Let's do the Laplace transform of t cubed times e to the, let's go negative 2t. Whoops. Try again. So in this case, you're going to do the third derivative of whatever you have for e to the negative 2t. So give it a go, and then I'll walk you through it myself. So in other words, you're going to do the Laplace transform. Here, I'll write it down. Negative 1 to the third times the third derivative of the Laplace transform of e to the negative 2t. So look that one up. You can find it. And then do that derivative. This one's way easier than the sine. Whoops, sorry about that. I'll put this back up there in just a sec. Just want to make sure I had everything ready. All right, let's do this. Preston, what's the Laplace transform of e to the negative 2t?
1 over s plus 2.
All right, 1 over s plus 2. Now notice that negative 1 to the third is going to be negative 1, so I'll just put that out there. And we're going to have to do the third derivative of this thing here. Fortunately for us, though, this isn't nearly as complicated as the third derivative of that sine thing. Whoops. Yeah, there. That was bad memories up there. So why don't I do this? I don't know if this helps you or not. S plus 2 to the negative first power. And we're going to do 3 derivatives. So 3 derivatives of that thing. So let's do them one at a time. Sam, can you do that first derivative for us? You got it? What's next? Derivative, not integral. Derivative. Negative 2, very good. And then you're going to multiply by negative 1. Yeah, so chain rule. So this is the chain. Oh. There. Now it's the chain rule. So you've got the negative 1 times s plus 2 to the negative 2 times the derivative of what's in there. So thank you, Sam, for being the first, because now the rest of them are going to be super easy, because you'll say, oh, I see the pattern. Anyway, this is going to equal just s plus 2 to the negative second. Okay, so that's the first derivative. We got 2 to go. Let's do it. Gabriel, can you do another one?
It would be negative 2, and then parentheses s plus 2, and parentheses to the negative third.
All right, beautiful. All right, one more to go. And Travis, you got it, right?
Yeah, 6 in parentheses, s plus 2 to the negative 4.
All right, that's beautiful. Let me just write that like this. And that's going to be the Laplace transform of t cubed e to the negative 2t. Now I got to mention something. We went over one of these when we were bending time and space. You remember doing this, where we shifting the time and space thing? And this is one of these that shifts time and space. So you actually have 2 options for this one. Let me remind you of the other one. The other way to do this is, instead of taking derivatives in the derivatives with respect to s and going through all that rigmarole, another way to do this is to focus on that t to the third. And what this ends up being is, it ends up being, you do the Laplace transform of t to the third, and then you shift by 2 because of that 2 right there. You remember doing this? Maybe? We'll pretend. Good, thanks for pretending. Anyway, the Laplace transform of t to the third is 6 over s to the fourth. And then shift by 2 gives you 6 over s plus 2 to the fourth. So you get exactly the same thing. Two ways to get the same Laplace transform in this case. So that there's not a lot of Laplace transforms where we can do that, but there they are. All right, so a challenge is going to be going the other direction, identifying when you have the inverse or a derivative like this. And fortunately, I think I've chosen homework problems where they're relatively easy, where you don't have to think of multiple derivatives. So let's see if I can think of one off the top of my head, and then we'll get to the flight plans and the number 5 there. So let's see if we can do the inverse Laplace transform of, how about 2s over s squared plus 1 to the second power. Now, I guess I've given you the hint that this happens to be, the derivative of a particular Laplace transform that you may be familiar with. But let's just give this a go, see if we can figure this out. And one way to attack this is to ask yourself, can you do the antiderivative of this thing? You see, up here, the Laplace transform, you're doing derivatives. And so if you want to try to undo those derivatives, it's of course the antiderivative. So let's see if we can do the antiderivative of that. I'll bet we can. Let's see if we got it. Yeah, I would have asked Corey, but he's not here. I'm sure he would know the answer though. So why don't I do it for Corey? So this is in Corey's memory. So the way that Corey would probably tell me to do this is he would say, use substitution. U equals s squared plus 1. du is 2s. Ooh, that's convenient, isn't it? Oh, ds, sorry. And so let's go ahead and we get, let's see, 1 over u squared du. Isn't that beautiful? And that's going to equal negative 1 over u. That look all right? So the antiderivative, 1 over s squared plus 1. The antiderivative of this is this, and that is a familiar Laplace transform. Take a look at your tables. I'll bet you can figure out which Laplace transform that is. So here's what's happening, is I'm going to do the inverse Laplace transform of negative 1 over s squared plus 1. And since I did one derivative, I'm going to have to multiply all this by negative 1 to the first times t to the first for the one derivative, or antiderivative in this case. So see if you can find it in your table. I'll bet you can. Avin, what do you got for that table for this one? Excellent. In particular, it's the negative sign because of this negative 1 up here. So this is going to be times negative sine of t. And so my final answer is going to be t times sine of t. All right, so do your best with these. Let's take a look at what's coming up. So flight plans. I knew about this situation. Here, let's see. I can even show you. Where is it? Where are my photos? Here we go. Let's see. Do I have it? Oh, there it is. So there she is. This is the. Isn't that beautiful? This is the recital hall at Gordon College, overlooking a koi pond. So anyway, there she is playing. And you can see that this is, it's on Sunday, but we're flying out on Friday to get there in time for this. Here's another one if you want to see. There she is. But anyway, so it's her senior recital. I figure I probably should go. I don't know. I was actually somewhat opposed, but then my wife said, no, you have to go. And I was like, okay. My mother's going. You got to go. Okay, I'll go. But anyway, so that's what's going on. That's why I'm leaving you. But I did know about this pretty early on, and I got it approved. Why is that like this? Just a minute. Oh, there it is. I got it approved, the absence. I have to actually ask for permission to miss classes, which I did. And so the plan, but I had to submit a plan of attack so that they would know that I actually had a plan. So here's the plan. You can find the plan on our homework page. I just updated it, but I'll show it to you now so that you know what's going on. And on homework it says, look at this, for 417, this is all the stuff that you're supposed to do between now and next Monday. You know, doesn't it look great? Okay, so number 1, take home exam 3, optional. Optional, it's right here. I'll give it to you in a moment. Number 2, this is also optional. Watch the 7.4 videos, section 7.4 online. You might wonder, where are those 7.4 videos? I can't wait to see them. I'll show you in just a minute. And you're supposed to watch the derivatives of transforms and the integrals of transforms. So we just went over derivatives of transforms, so you can skip that one if you don't want to watch it, or if you want to get a little bit more instruction, you can watch it and see what I did during COVID, because both of these are from the COVID tomfoolery. Anyway, getting back to this, also, notice that there's a big long homework assignment, but that kind of spans 2 sections. It's what you would have done for Friday plus what you would have done for Monday. So hopefully you can suffer through all of that. Do your best, and we'll pick up the pieces on Monday. Now, you might be wondering, where are these week 7, section 7.4 videos? Because I can't wait to see them. Well, go back to the Moodle page. If you haven't done so, you will see here under the videos from the summer of COVID, week 7, and maybe it'll start. I clicked it. Here we go. So here they all are. Are they going to work for me? Maybe or maybe not. Doesn't matter. But they're right here. It's this one. Derivatives of transforms is the one that you're going to want to watch. If you choose to, there's some examples that I do here on paper. And then we've got the 7.4, the integrals, and some examples, and then, oh, that's it. Yeah, okay, so that's all we got. I thought, okay, yeah, apparently no one had trouble with this during the COVIDs, because you'll notice here that there's this blank spot for homework help. No one asked me for help, so I didn't give any help. However, if you do have help that you need, you can always bug me, and I'll help you on Monday, I guess. Okay, so do you have questions about flight plans? These are plans for the absence plans, is you get to watch a video if you choose. You don't have to, you can just go do the homework. And also the take-home test, so the another test. And another? Yes, another. That'll be the final test before the final, which is the Friday before finals. I think it's like the 20-something, 27, 28, whatever it is.
28.
28? Yeah, that Friday. So just so you know, just put it on your radar, and here's what I'll do. When I make that test up, I'm going to take the test that I would have made you and then do this to it. Make it the easy version as penance for having made you suffer last week. I reckon I was suffering when I was grading it, to be honest. So it was pretty ugly. So let's take joy in our differential equation. So are there other, oh look, my battery's running low. Guess we're done.
You've been using it as like.
Okay.
Thank you.
I'll give the manhandles one to someone else.
Okay.
Yeah, I don't need that. I don't need that.
You don't want one, you don't have to take it. You don't have to do it if you don't want to. Yeah, seriously.
Yeah, I
You don't have this option.
it's really just, some would say, time consuming.
Yeah, it's just perfunctory for you.
Yeah, I know.
You want-
I don't need it.
You want the manhandle.
It's gotta get it.
Someone's gonna get it.
I'm so glad.
There's 2 pages, they should be different. Oh wait, Aaron, did I give you 2 copies?
Yes, I'm pretty, yeah, you did.
No, Art,
Wait, no, you
it's
didn't.
2 pages.
No, you didn't.
Sorry, I got confused. I got it
I
signed.
attempted number 1.
Here you go. Here, bring this to Corey, he will be so excited.
Alrighty, I will.
Thank you. What is this? This is something?
Should I turn that on? I didn't know how to do that. No?
What is this?
Homework. I think that would have been your last one.
Oh, last Wednesday.
Yeah.
Oh, yeah, what's that?
Yeah.
Oh, yeah, nice. Yeah, sure, you can turn it, why not? Sure. Look at that, that's just blank. That's all right, Clayton, you're not alone. All right, yeah, I'll take whatever you got. and I'll
Thank
put
you,
in the
Dr.
stack.
Noonan.
Thank you, thanks for, yes, that's beautiful. Thanks for being here. This for me too, all right, very good. Yes.
No,
Oh.
somebody else.
Yes, it is.
I did one.
Any letter of recommendation?
Oh, that's fine.
If they need someone other than those people downtown, let me know.
Thank you.
Because I mean, you'd believe that. I mean, it's shocking.
I was shocked as well.
I-
I thought that test did not go
It
good.
was ridiculous, and yet, I mean, yeah, perfect. I mean, well, not perfect, there were a couple of minor,
Yeah.
but nothing, yeah, nothing big. It was incredible, so.
Thank you.